Hello! Welcome to this HEEDS Technical Insights video, devoted to the topic of HEEDS AI Simulation Predictor. With this video, we assume that you are already familiar with the product called HEEDS and leveraging it to discover better designs faster. Today, we will showcase a new search addition to HEEDS called the HEEDS AI Simulation Predictor. Added to the HEEDS MDO product in version 2310, this additional module is the latest enhancement to the search strategies within HEEDS, devoted to helping you discover better designs faster. In this video, we will introduce HEEDS AI Simulation Predictor and its intended applicability. Before doing so, however, we will review the motivation for this technique, look at the role of HEEDS in generating data, understanding data, and representing data for reuse, then look at a case study to reinforce these aspects of HEEDS. The same case study will then later be used to show the benefits HEEDS AI Simulation Predictor can offer. We'll conclude with a second application example and a discussion on data reuse as it pertains to HEEDS AI Simulation Predictor. Let's get started. Let's begin by looking at the motivation behind the larger theme where HEEDS AI Simulation Predictor is applicable. In particular, we are focused on design space exploration within three primary areas. Here, we reterm design space exploration more broadly as generating data against goals. Whether prescribing designs to automate within a workflow or leveraging more advanced search techniques like optimization or adaptive sampling, the primary goal is the generation of data for consumption to improve product design against intended goals. As it pertains to HEEDS AI Simulation Predictor, we will restrict the focus to solely on optimization. Once we have data generated, we then have the task to understand the data generated. With the creation of hundreds or even thousands of data points, we need smart, automated techniques to interpret and maximize the benefits of knowledge attainable from the data. In this video, we will not focus extensively on this aspect of design space exploration, but it must be appreciated as a fundamental value add. Please check out some of our other HEEDS Technical Insight videos devoted to data mining with our dedicated post-processor, HEEDS Post. Finally, with the data generated, we want to represent and reuse the data as best we can. This could be through the usage of reduced order modeling, where we are approximating the design landscape through various forms of surrogate or meta models. We'll learn today how this aspect is a key component to HEEDS AI Simulation Predictor. Let's briefly recap how the HEEDS product line helps us against our motivation for the topics at hand. Recall, HEEDS has four foundational enabling technologies at its core. Process automation allows for the auto-generation of the data using direct interfaces, or portals, to common CAD and CAE solutions. By chaining tools together in a process with seamless data transfer and connectivity between tools, HEEDS is able to replicate an engineering workflow in an automated fashion. With the software automation prescribed, distributed execution allows for the designation of the appropriate software licensing modules and hardware specifications to attain maximum throughput of the data generation within the automated process. Whether running locally, on an HPC or in the cloud, HEEDS makes it possible to rapidly configure a workflow to your hardware resources. With a fully defined automated workflow and linked to the designated hardware, the next enabling technology is the efficient search component of HEEDS. This is the piece of the technology that allows for the data generation against goals, with the latter against goals part of the statement being the focus. With state-of-the-art search technology, HEEDS is able to rapidly generate data of value against the intended performance goals. It is this area that we will focus on today. And finally, as noted previously, the leverage of post-processing techniques on a common platform is also key to the value HEEDS offers. This data interpretation component is what we term insight and discovery. The focus of today's Technical Insights video revolves around the efficient search pillar. Specifically, we are focused around iterative learning as it pertains to optimization. Within HEEDS, we have a proven solution for meeting innovation goals which is easy, reliable, and efficient. The Sherpa search framework is a hybrid, adaptive approach to optimization which leverages various optimization algorithm techniques and strategies simultaneously. With the unique proprietary methods it deploys, it has been proven to solve a wide array of problems doing both global and local search simultaneously. In doing so, it is able to overcome the typical challenges associated with optimization with a singular algorithm by blending the strengths of various methods and algorithms in a unique way. This is the hybrid aspect of Sherpa. Additionally, Sherpa is adaptive in the sense that it tunes itself to the design space as it runs. It learns about the landscape and in doing so, in real time alters how it searches the space. It is this adaptive nature that allows it to uncover innovative solutions faster and against a singular user input, that being the design budget. On top of all of this, the Sherpa search framework is extremely simple to use, eliminating the need for variable screening, upfront DOE, model simplification, manual iteration, algorithm selection and tuning, and many of the other historic challenges associated with optimization. In practice, Sherpa works to find the best combinations of variables to attain your goal, set by the user-prescribed objectives and constraints. In this diagram, our goal is to be as low on the y-axis as possible within the prescribed budget. The budget here is represented by the maximum allowed number of designs on the x-axis. Upon launching the optimization, Sherpa goes about navigating the design landscape against the prescribed budget with automated exploration. As noted prior, Sherpa is robust, efficient, and easy to use. With that backdrop for today's focus area, let's take a look at Sherpa in action via case study. We'll thereafter introduce how HEEDS AI Simulation Predictor can supplement and accelerate Sherpa even further. For our case study, we'll look at designing an unmanned aerial vehicle under prescribed flight conditions. Our goal is to design the wing profile of the UAV for airfoil glide performance, while ensuring shock volume is within prescribed limits, the loading center of gravity is maintained for the aircraft, and the connectivity point of the wing to the fuselage is maintained. Here we utilize NX-CAD for the parametric CAD model, Simcenter CCM Plus for the computational fluid dynamics simulation, and HEEDS MDO for the resulting optimization. Transforming our goals into an optimization problem statement results in the statement shown here. The goal is to maximize the lift-to-drag ratio of the wing, as predicted from Simcenter CCM Plus, while ensuring the shock volume computed from Simcenter CCM Plus is less than or equal to 0.02. Simultaneously, loading and geometry intersection checks are extracted from NX. The NX parametric CAD has been built such that there are 12 geometric variables, 10 of which determine the shape of the airfoil, and 2 of which the shape of the wing, notably the angle of attack and the sweep. With an aim of generating our data against the prescribed goals, we first start with a validated baseline design. We then build up our automated process within HEEDS, leveraging portals or direct interfaces to NX and Simcenter CCM Plus. Through the tagging process in HEEDS, the variables and responses are then associated with the parameters in NX and Simcenter CCM Plus. This results in an automated process with the parameter connectivity driving the ability to optimize against our goals. With the automated workflow in place, Sherpa is utilized for the optimization to uncover innovative solutions. Here, we will let a sped-up animation of the design space exploration play as Sherpa navigates the design landscape. At the conclusion of the design space exploration, indeed Sherpa has found an innovative solution, performing drastically superior to the baseline design performance in this case. Of note is the fact that the best design was found within a few hundred evaluations using the hybrid adaptive search framework of Sherpa. We will now see how HEEDS AI Simulation Predictor can further accelerate the discovery process with something we call boosting in HEEDS. With all of the benefits we've spoken about, and the speed and ease with which Sherpa operates, the reality is that there can still be bottlenecks to design space exploration today. Many simulation models still have very long compute times, making the possibility of running hundreds or even thousands of variants sometimes daunting. Many organizations are encouraging a shift left, whereas design work is focused throughout the development cycle and not just at the design phase as we may be accustomed to. There remains challenges related to reliability and robustness, taking into account manufacturing and operational uncertainties. And additionally, re-leveraging data is more important than ever before as many organizations continue to adopt and grow their simulation capabilities. HEEDS AI Simulation Predictor was developed specifically to help address these challenges. As an AI solution to boost optimization studies, HEEDS AI Simulation Predictor uses accuracy-aware AI models to supplement predictions from the costlier simulation models to speed up the design space exploration process. Let's learn how. Returning to the graphic used earlier to help describe how Sherpa works, we'll use a similar approach to describe how HEEDS AI Simulation Predictor works. The first thing to note is that Sherpa is still the underlying search technique, making the decision as to what design points to evaluate next. So the exact same Sherpa search framework is deployed here. The AI techniques about to be introduced are an overlay on top of Sherpa, as we'll see. So how does it work? First, the initial part of the exploration process is the same, where all designs evaluated are selected by Sherpa and run with the full CAE simulations. This is done for a designated period of time, by default for the first 100 design evaluations. Thereafter, HEEDS AI Simulation Predictor is deployed, where accuracy-aware AI models are trained against the initial data generated from CAE evaluations that Sherpa generated. Thereafter, Sherpa continues to decide on variable combinations for each design iteration. However, HEEDS AI Simulation Predictor determines whether the responses for the given combination come from the accuracy-aware AI model or the real CAE simulation. Thanks to the accuracy awareness inherent with these types of AI models, HEEDS AI Simulation Predictor governs for a given design, whether its predicted value from the AI is sufficient against the overall goals or if the simulation should be conducted instead. This decision is made based upon the regionality relative to the constraint thresholds, the known historical accuracy as well as the predicted performance of the given design, and also the necessity for further accuracy improvement obtained from a higher performing CAE simulation. Crucially, HEEDS AI Simulation Predictor ensures that the highest performing designs and critical designs near a constraint boundary are evaluated on the real CAE simulation. As a result, the rest of the design space exploration consists of a combination of both real CAE simulations and designs that only have predictions coming from the AI models themselves. Throughout the remainder of the optimization, periodic retraining occurs, by default every 50 CAE design evaluations, resulting in improved predictive capabilities and better accuracy awareness of the AI models as the design space is explored. With Sherpa still driving the search, innovative goals can still be attained and a similar best design can still be found within the allocated design budget. However, if we alter the perspective from design budget to throughput, or overall time, then this means that similar best designs can be found faster. Why is this? Because now, instead of all designs that make up the optimization budget being evaluated with a time-costly real CAE simulation model, only a portion of those designs are physically simulated, with the remainder being evaluated instead by a much faster AI predictive model. If we compare the Sherpa-only graphic with that from Sherpa combined with HEEDS AI Simulation Predictor, it can now be appreciated that HEEDS AI Simulation Predictor can make best-in-class even faster. The alternative way to look at this also is to consider that typically our design budget is based on a fixed time. For example, I need a solution by next Tuesday. If we consider the same premise in looking at advantages of HEEDS AI Simulation Predictor, we can appreciate that we now have more time that we can allocate to the optimization. This yields the potential that even better solutions may be found than previously, thanks to the fact we can now process more designs during the optimization within the specified time period. So when is this solution applicable? First, it should be used only when there are a high number of evaluations. Here, we are considering high number of evaluations as optimizations where the total budget is 400 designs or more. It is possible to leverage with smaller budgets as well, but in practice, 400 or more evaluations have been shown to have the greatest benefit routinely with default AI training settings. Secondly, the underlying CAE simulations should be long-running. Here, we mean that if your simulation model only takes a few seconds, you probably should not consider leveraging AI as a supplement. Why? Because the potential time-saving gains are mitigated by the time spent periodically training the AI models. So, if you have simulations that take multi-minutes or hours to run per design, then HEEDS AI Simulation Predictor is likely something you will see considerable benefit from. Faster running simulations will see less benefit. Lastly, greater benefit is seen with greater number of variables, as that correlates with a typical increase in the number of evaluations required for good results as described by our typical best practices relating to the number of evaluations recommended per design variable. If a low number of variables, it is unlikely that you are running more than 400 evaluations anyway, since Sherpa by itself is so efficient. Now, with a fundamental understanding of what HEEDS AI Simulation Predictor is and how it works, let's return to the UAV example we solved earlier with HEEDS and Sherpa and see how HEEDS AI Simulation Predictor can help us on this problem. We have the same problem statement we saw earlier. When we ran this prior, we ran for 500 evaluations with a computationally expensive CFD simulation model with 14 variables. This problem is therefore well suited to leverage HEEDS AI Simulation Predictor. As such, we will compare and contrast solving this problem with solely Sherpa, as shown earlier, and when we boost Sherpa with AI. The same total evaluation budget was given as 500 for each optimization. We are concerned with first ensuring we can find a similar solution when leveraging HEEDS AI Simulation Predictor, and secondly, if so, what type of time savings do we see? For this problem, we found a similar solution when leveraging HEEDS AI Simulation Predictor to when we didn't. The same exact design was not obtained, however, for all intents and purposes, relative to the baseline performance, a similar innovation goal was attained. When the study ran just with Sherpa alone, it took 31.5 hours of total clock time to conduct the optimization, utilizing the prescribed allocation of compute hardware. The identical allocation of compute hardware was subsequently then used for the optimization that utilized HEEDS AI Simulation Predictor with Sherpa, resulting in 12.5 hours of total clock time. As such, 19 hours or 60% of the time was saved thanks to HEEDS AI Simulation Predictor. Since only 201 designs out of the 500 total designs were performed with the real CAE simulations, and the other 299 designs coming solely from AI predictions, drastic overall time savings were obtained. The benefits of HEEDS AI Simulation Predictor come into focus when considering the time savings, reduction in compute hardware, and development costs associated with this problem. In watching the animation on this slide, we can begin to appreciate how this is possible. The top objective history plot differentiates through auto-generated design sets by HEEDS, the feasible and infeasible solutions from real CAE simulations, CFD here, with those predicted solely by the AI. The bottom plot shows the time savings attained as a result of leveraging AI here. We see that the first 100 designs saw no savings as part of the initial training cycle, but thereafter savings are differentiated between feasible and infeasible solutions. What this graph shows is that of the 60% time savings seen on this problem, 40% is attributed to AI substituting simulation for infeasible solutions and 20% for feasible solutions. This AI substituting for infeasible solutions more than feasible solutions is typical and a trademark of the uncertainty awareness acumen of these AI models. It should also be noted that majority of the high-performing solutions are still evaluated with the real CAE simulation, either as a validation of the AI prediction, as a means to further enhance the AI model, or due to the fact that they are very close to the constraint boundary, all again properties associated with the accuracy awareness of AI models within HEEDS AI Simulation Predictor. Let's look at a second example of leveraging the HEEDS AI Simulation Predictor to discover better designs even faster. It should be noted that the second example we are going to look at has entirely different physics than the first example. Here, we are solving an automotive structural problem using the LS-DYNA explicit crash solver for finite element analysis. Just like HEEDS itself, HEEDS AI Simulation Predictor is physics and tool independent. It matters not whether solving an aerospace CFD problem, automotive crash problem, consumer product linear FEA problem, or any other industry or domain problem. As long as it meets the suitability guidelines prescribed earlier for an optimization problem, it is likely HEEDS AI Simulation Predictor can further streamline the optimization turnaround time for you. In this case, we are looking to optimize the frontal rail on an automobile. We are only modeling the rail itself being impacted by a rigid wall with the prescribed velocity and mass. Our goals are to maximize the energy absorption by the rail with a certain crush deformation shape while ensuring mass is reduced and taking into account acceleration requirements. Formulated into an optimization problem statement, we have a single objective to maximize the progressive energy absorption per unit mass while ensuring the peak reaction force is below a prescribed threshold. There are 45 geometric variables dictating the shape of the rail and one thickness variable. As before, due to the expensive crash simulations and the highly nonlinear design landscape, we would like to decrease turnaround time, leveraging HEEDS AI Simulation Predictor. As such, to understand the benefits of AI on this problem, again we have run two separate optimizations, one utilizing only Sherpa and the other leveraging Sherpa plus HEEDS AI Simulation Predictor. Let's take a look at how to enable HEEDS AI Simulation Predictor within HEEDS. We already have an automated process and fully defined project, as would have been set up for our Sherpa optimization without HEEDS AI Simulation Predictor. To enable the HEEDS AI Simulation Predictor, all we have to do is go to the Study tab and access the additional Boost sub-tab. It should be noted that the ability to use HEEDS AI Simulation Predictor requires an additional licensing feature that is not standard with HEEDS MDO. If that license feature is not available, the contents of the Boost tab will be grayed out within your HEEDS user interface. Since we have the necessary licensing module, when we click on the Boost sub-tab, we have the ability to enable HEEDS AI Simulation Predictor. To do so, we need only choose the analysis or groups of analyses to be boosted with the accuracy-aware AI models. Upon doing so, the boost properties appear. Typically, the default properties work well and should not need to be changed. We see that by default, the initial training period cycle is 100 designs, with retraining occurring every 50 CAE simulation designs, as noted prior. For more information regarding the boost properties, please refer to the dedicated documentation. For this problem, we found a solution with HEEDS AI Simulation Predictor, which was better than that found with Sherpa alone. Both solutions were considerably better than the baseline design in terms of energy absorption. The best design found with HEEDS AI Simulation Predictor was considerably superior to that found with Sherpa alone in terms of energy absorption, but was heavier in the end. For the Sherpa-only optimization, it took 46 hours to conduct the optimization. With HEEDS AI Simulation Predictor, in conjunction with Sherpa, it took only 21 hours to conduct the optimization since only 230 evaluations performed the actual crash simulations. Again, the time savings, 25 hours in this case, is evident in what HEEDS AI Simulation Predictor can offer. Finally, let's consider an additional important aspect to HEEDS AI Simulation Predictor: data reuse. One of the key aspects of understanding when considering HEEDS AI Simulation Predictor is the concept of full-order models, referred throughout this video as real CAE simulation models. The idea behind HEEDS leveraging AI is to supplement this with a trade-off between fidelity and speed, through leveraging of various AI techniques that can be classified broadly as reduced order models or ROMs. Reduced order models in this context are representative, lower fidelity models of the design landscape or regions of the design landscape. As it pertains to optimization, leveraging reduced order models intelligently, in our case through accuracy awareness, can allow for considerably faster predictions where appropriate. However, applicability of ROMs always goes back to the data itself and ensuring that we maximize the utilization of the data available. So how does data reuse come into play with HEEDS AI Simulation Predictor? First, we need to consider where the data sources reside in generating the AI models. One option is that the data can come as part of a new design space exploration, as we presented earlier. In this scenario, Sherpa is generating the data for us as part of the same optimization we are boosting with HEEDS AI Simulation Predictor. However, if we have data already available from past similar optimizations, we can map that data to our new problem and re-leverage the investment already made in obtaining that data. The HEEDS AI Simulation Predictor will over the course of the run learn about the accuracy associated with that data as a means for its decision-making, and supplement that knowledge with new data gathered from the new optimization problem. If the data is a one-to-one mapping, then that makes the ability to fully leverage the data even better. To extend from this theme, in reality, the data can come from anywhere, be it test data, experimental data, simulation data. HEEDS AI Simulation Predictor allows us an opportunity to better leverage data as a means for reuse. Once available, regardless of source, Sherpa makes decisions with the AI overlay, guiding when to simulate versus use the AI predictions, as we saw in our prior examples. Finally, it should also be noted that the resulting AI models from utilization of HEEDS AI Simulation Predictor themselves are reusable, either as a launch point for future design space explorations, or as a ROM itself in another HEEDS workflow. HEEDS AI Simulation Predictor has been built with data reusability at the forefront. This concludes today's technical insight video devoted to the topic of HEEDS AI Simulation Predictor. We are excited to bring this new offering to our customer base as the next cutting-edge search technology offered as part of the HEEDS search framework. Thank you for watching.